Okay, welcome. Good morning and welcome to Beam Day. It's great to see so many people on a Sunday coming to think about the future of Ethereum. And yeah, today we have a really packed day. So yeah, let's get started. What I want to do today is zoom out a little bit. We're going to have many talks that are going to zoom in into specific topics, and I want to kind of share some thoughts on the broader strategy, because what we have on our hands is an extremely ambitious project, to say the least, and so we need to have some sort of a plan, and this is, I guess, some of my thinking, which is still evolving. So in the first part of this talk, I'm going to share ideas for strategies that apply for the whole Beam project. And then in the second part, I'm going to talk about specific tactics that we can employ for modules of the Beam chain. And one of the themes in the tactics is to try and use time as leverage, where things kind of age with like fine wine. Okay, so the very first strategy is just to keep projecting out. So the mental model that I have here is that we have the status quo on one end of the spectrum, where we are with Ethereum today, and we have the idealized platonic state of Ethereum, where it could be if everything was perfect. And in some sense, the goal of Ethereum research is to push the state of the art and to try and minimize the delta between what we know is possible and what is actually possible. And one of the realizations in the last few months and years is that maybe this delta here is very small. Like more and more we're finding results that are lower bounds, basically that prove that there isn't much space to improve things. And so, I have this kind of big dream in some sense to try and get Ethereum to the state of the art. And I believe there's an enormous gap here between where we are and where we could be. And really what the Beam project is all about is kind of this mentality, this attitude that we would start with the state of the art and walk backwards, as opposed to starting with where we are and going forward. So we're trying to minimize path dependence, and we're trying to take a fundamentals, first principles approach to things. And hopefully, at some point we kiss in the middle, and if Ethereum is in a great position. Now, this is a bit of a personal slide, but I've been working on many different projects in the last couple of years. And what I'm trying to do is spend more and more time on the Beam project. But in order to do that, I need to find ways to delegate these projects here. And I'm sharing this slide kind of tentatively, but there's various people who I'm hoping will be able to champion some of these efforts here. So we have Drew for the base rollup, Luca, this is shared confidentially from Late2Beat, might be championing native rollups, and we also have Farah in this room who might be championing the ETH-proof project. And so I'm hoping that all of these other projects can be segmented away, and I can spend most of my time on the Beam chain project. Now, there's a lot of stuff that we can improve in the consensus layer. And what I think we should do is try and pick the right battles. We need to basically focus on the things where we have the most leverage. Now this is kind of this mental model that I introduced in my DEF CON talk, where there's 3 buckets of improvements, and each bucket has 3 meaty improvements. So in the block production bucket, we have censorship resistance, attested firewalling, and shorter slots. And one of the amazing outcomes of the last few months is that we actually have EIPs that move in that direction. So the incrementalists are very much excited about improving the block production. We have a fossil EIP. There was a proposal to include it in Amsterdam. It might go into the H fork, we'll see. There's also EPBS, which is an incremental step towards APS. That's gaining a lot of momentum recently, especially since Berlin. And we also have a proposal to shorten the slot times to 6 seconds. So So all of that is things that we want, and because others are working on it, maybe we don't have to spend that much time on. Another strategic thing that I would not spend much time on is the issuance. The issuance is a very political and sensitive topic, and the nice thing is that it is very encapsulated. All of the complexity is in the macroeconomic thinking, and then it distills down to just one line of code, which is the issuance curve. And so my suggestion is to punt this to after the beam fork, and not spend any resources on it right now. And a similar thing could be said with the VDF project, which is trying to improve the randomness. By the way, I brought one of the VDF rigs that we manufactured. And the reason here is that all of the complexity is encapsulated in the hardware. And again, it's one line of code essentially to integrate it into the beam chain. So what should we focus on? Well, I would argue that the highest priority is actually this moon math cryptography, both the quantum security for the attestations and the proposals, as well as the snarkification of the chain. And the good news is that not only is it the highest priority in my opinion, but it's where we're making the most progress. And I think we should also focus on the staking, including 3SF and rainbow staking. And the good news here is that we already have a rich body of literature that have pushed the state of the art, and things like 3SF at this point in time are fairly well understood. So what I would do basically is have this strategy where we anchor ourselves in something of very high quality, the post-quantum testnet. We nail that part of it, and then we grow from that point onwards incrementally, which is called the beachhead strategy, right? So we establish a beachhead with post-quantum, and then we move our way up to related topics. And if we can nail this, then I think we'll be in a fantastic position to nail the other things, and it's part of the reason why we'll have a roundtable later today on the post-quantum testnet. Now, another strategy is, with such an ambitious project, is to be pragmatic and reuse infrastructure where possible. And this is a slide that I had in DevCon. There's a lot of infrastructure that we can reuse, from libraries to even funding infrastructure. And I think we also have an opportunity to partner with lots of teams that didn't exist when we were doing the beam chain. So we didn't have a DevOps team, a security team, incentive team, testing team, and networking team. All of that is stuff that didn't exist when we did the beam chain, so the beacon chain. So if we were able to ship the beacon chain without it, and also without all of that stuff, all of that basically had to be built, I think we're in a great position to be successful. Now, one question that I get asked a lot is, do we need 9 new consensus layer teams in addition to the 6 existing ones? Do we need 15 teams? And I guess there's 2 parts to my answer here. One is that I'm expecting natural consolidation. Historically, for the beacon chain, we had 10 new teams appear, and those consolidated down to 5. I'm expecting something similar here. But also, what I would encourage is specialization. And we're starting to see this. So for example, the Quadrillium team, they are networking experts, they're the creators and maintainers of the C++ library, and I think it makes sense for them to focus on that as a library. Similar story for Kakarot, right? They are snarkification experts in the context of Cairo, and I think it makes sense for them to focus on just the state transition function and its snarkification. And there's all sorts of other opportunities as well for teams to specialize. So for example, we need to have the post-quantum equivalent to BLS. Someone needs to write that, and that could be a library that is beneficial to all of the teams. And there's also some middleware around having multi-client infrastructure for multi-proving and all of that stuff. Now, one of the things that has happened recently is there's been a massive reorg at the Ethereum Foundation, specifically when it comes to the protocol R&D. And we basically have a new captain, or new captains, one of which is in this room. And on June 2nd, they basically made this announcement that we have these new strategic objectives. And what that means is that for the short term, for the next 12 months, we have things that we want to do, which are scaling DL1, scaling the blobs, and improving UX. And one of the things that you notice here is that the Beam chain doesn't fall into any of those short-term priorities. And so what we need to do is just need to be patient until June 3rd, 2026. And I think at that point, we can start becoming more aggressive. So for a period of a whole year, I think what we need to do is basically put our heads down and basically do the best work that we can in preparation for the medium-term future. Now, this is one of my slides from the DEF CON talk. I would actually argue that it's my most hated slide ever because the people complained about how the timelines are so long. But I think I like this slide. I think there's nothing wrong with it. And one of the things that has happened is that the pilling phase, I would argue, has successfully ended. And now we have these 15 candidate Beam teams, 6 plus 9, that are potentially going to be building clients. And now we're very much in the speccing phase where we're writing sub-specs for different modules, and eventually we will produce a full feature complete spec. But going back to the first point, there's going to be this period of time here where we should not disturb the existing devs, right? Because they have this very important mission around the short-term strategic objective, and so we should time the release of the Beam spec not too early. Okay, any questions so far? Okay, great, let me just move on then. So, part 2, tactics. So here what I'd like to do is focus on individual work streams within the Beam project, and oftentimes highlight this nice thing that time is usually to our advantage. That the Beam project spans multiple years, 3, 4, maybe 5 years, and the fact that we have so many years is actually a structural advantage, which I want to highlight. So what is the plan for Poseidon? One of the amazing coincidences is that SHA-256 and Kitchak were both 8 years old when they were included in Bitcoin and Ethereum, respectively. It's kind of a coincidence, but what I'm hoping we can do is basically have a similar story for Poseidon. Poseidon is 5 years old, and hopefully over the next 3 years it will really mature into a very robust and trusted hash function. And there's all of these efforts to accelerate this maturation process. So for example, in the first half of 2025 alone, the Ethereum Foundation has organized 3 different cryptanalysis workshops in 3 different locations, inviting experts all around the world to try and break these hash functions. And we've also given 6 different grants to teams around the world to think about breaking this hash function over the next 6 months. And so I really do think that if nothing happens and no breaks are found, then in 3 years' time we will be in a great position, and Poseidon will have aged like fine wine. The post-quantum cryptography is going very well, and one of the features here is that we have a very modular design with different components and different people working, different experts basically, working on the different modules. And one of the nice things here is that we have designs which are extremely simple and in some sense close to optimal. And one of the nice things is that where most of the complexity lies, which is the signature aggregation, we're going to benefit from SNOCs improving over time from the broader industry. So in the short term, we've started the process of building a minimal ZKVM to SNOCify the attestations recursively, and this ZKVM should improve over time as the state of the art of research also improves. Now, one thing that I'm curious to see how it unfolds is the quantum narrative. It seems that every quarter, every 6 months, the drums get louder and louder and louder as we get quantum computers with more and more qubits, and the algorithms improve. One of the amazing things that happened is that last year, the state of the art for breaking discrete log was an algorithm that required about 10 million physical qubits. And then earlier this year, that number was brought down to 1 million physical qubits. And now, just a few weeks ago, we had a new paper which brought it down to 400,000 qubits. So we have the quantum computers that are increasing in qubits, and then the algorithms improving. And it's possible that this quantum narrative, again, is going to age like fine wine to our advantage. Snarkification. The amazing thing here is that all the industry is just doing the work for us. We can just sit back and relax. This is the ZKVM tracker from Eve Proofs. And what's happening is that every week we get a new tick and a new green box. And so by the end of this year, basically this whole section of the spreadsheet should be essentially completely green. And we'll be able to reuse all of that super sophisticated ZKVM infrastructure to our advantage without doing any work. And we're going to have a talk this morning that is going to kind of highlight the fact that this is happening in practice. So RISC-0 is going to basically be announcing that they've managed to snarkify the whole beacon chain as it exists today, and that really bodes very well for snarkifying the whole beam chain as well. Now, finality, I'd say, is also going pretty well. So we have a whole team within the Ethereum Foundation dedicated to consensus and finality. And what needs to be done? Well, Vitalik wrote this minimal spec, which is 112 lines of code. We need to do some last mile integrations, and we need to do formal verification. And what I think will happen is that here again, time is to our advantage in the sense that a lot of the competitive blockchains have much faster finality on the order of seconds. And so, every year that passes is one where there's more of a desire for Ethereum to catch up with the state of the art. Rainbow staking. We're going to have a whole talk on this, but the basic kind of TLDR of rainbow staking is that we take validators, which are very bundled, a very bundled role, and we unbundle it into attesters, includers, proposers, and delegators. And one of the advantages of rainbow staking is that for the last 3 roles, the barrier to entry is extremely low, both technically and financially. You only need one ETH. And for the attesters, the plan here is basically to have a capped number of attesters, because that's limited by the number of signatures that we can aggregate per slot. And over time, through Nielsen's law, which is the improvement of bandwidth, 50% per year compounded, we'll be able to increase the number of validators that we support all the way potentially to 1 million validators. So the idea is to basically aggregate a whole million validators, signatures per slot. Okay, I already mentioned that block production, we have these 3 EIPs, and basically the plan here is just to make small improvements, right? If you take ePBS, for example, in order to get APS, you just need to add an auction mechanism. Which auction? It could be execution tickets, it could be executions auctions, it could be execution staking. There's a whole design space, but a lot of the complexity is basically handled by ePBS. And then for Fossil, what I expect will happen is that the beacon chain will have vanilla Fossil, and then there's all sorts of improvements that we can add on top, like light Fossil and ZK Fossil, if we deem that to be valuable. Okay, one of the final slides, issuance. So I already mentioned that issuance is a very delicate topic, but I don't think it should be completely forgotten. And the thinking that I have here is that this trend here is going to be like a pressure cooker, right? The more stake we have, the more negative externalities that we have, and more and more issuance, for example, more and more pressure to have LSTs, more and more pressure to not have ETH, be allocated to DeFi, things like that. And I think that that's going to ultimately lead to a breaking point where the community will say, yes, now it's clear to us that we have to change the issuance curve. And the tactic here basically is to do all of the preparation necessary so that when this day happens, it's just a one-line change of code in order to implement this issuance change within consensus. Okay, that's it. Happy to take questions, and yeah, looking forward to the talks coming up.
I didn't quite get the part where a proposer like this unbundled version of the validator. The proposer will only need to stake 1 ETH. That's yeah, I'm a bit surprised by that. So could you explain?
Yeah, so the way that the unbundling happens for proposers specifically, and here I'm talking about execution proposers, is APS. So the way APS works is that there's some sort of auction, and so for example, execution tickets. You buy tickets ahead of time, and then there's some sort of a lottery process to determine who will be the proposer for that slot. And in order to participate in those auctions, the minimum amount of ETH required would be 1 ETH, and this is just a very basic denial of service protection. Yeah, so this is fossil, this is APS, and this is delegation, which is the standard now for proof of stake.
So with the attesters, like you said, it would start with quite a low number. I can't remember, was it 32K? Do you kind of anticipate, or 16K even? Yeah. Do you anticipate we're going to have to massively reduce the number of attesters and kind of gain them back over time? And do you see that being a problem?
Okay, so the good news is that today we only actually have 8,000 operators. So the reason why I kind of think 16K is a good number is because there's a lot of buffer relative to what we have. The bad news is that we don't have consolidation yet. So what I'm hoping will happen is that when we introduce post-quantum public keys, the existing validators can specify the same key for all of the validators that they control. So it's going to be basically speeding up consolidation above and beyond what we're going to see with MaxED. And yeah, the main worry that we have basically is that if a very large entity, for example Coinbase, decides to not consolidate, they want to be maximally adversarial, where they split all of their stake into equal sized validators that are just at the limit, then that could be a denial of service, and it could push up the minimum amount of stake to be a validator way beyond 32 ETH, potentially closer to 1,000 ETH. And so what I'm hoping will happen is that in the shorter term, we can rely a little bit on social dynamics, whereby Coinbase are not trying to be adversarial as we know them today, and then over a period of just a few years, kind of harden the L1 to reach 1 million validators. And the reason why it grows by 4 every time here is because the proposed signature aggregation is a two-layer aggregation, and when bandwidth grows by a factor of 2, you actually get a compounding on the 2 layers. You get a factor of 4 increase in the total number of signatures that you can aggregate. And so every 2 years, bandwidth doubles. So every 2 years, we should be able to increase by 4. And so this is only an 8-year kind of journey, where the only thing that we're doing is just changing one parameter as internet bandwidth improves.
There are no aggregators on this slide. Do you consider them kind of as part of attesters, or they are just altruistic members that do not have any stake? What's your view on that?
Yeah, so my mental model for who are the aggregators is that they're primarily a subset of the attesters. And specifically my assumption, which I think is a reasonable assumption, is that 10% of the attesters will have the compute necessary to do the aggregation. So 90% of attesters can be on the Raspberry Pi Picos or on phones or whatever, and then 10% can be on a laptop powerful enough to do the aggregation. But I think it would be nice, and I think that's the natural design, to make the aggregation permissionless, so that anyone above and beyond who's not an attester can still help with the aggregation altruistically. And yeah, the way that it would work in terms of selecting the aggregators, and this is something that is good for the devs to be here, is that I'm hoping that the default is that you are, so I'm hoping that the way that the clients are built is that when you boot up your client, it tries to aggregate 1,000 signatures, for example, and it times how many milliseconds it takes. If it takes less than 100 milliseconds, then you're automatically enrolled as an aggregator. If it takes more than 100 milliseconds, then your computer is a bit too slow, and we're not going to enroll you as an aggregator. But overall, you won't even notice that you're an aggregator, because the CPU load and whatnot will be tiny.
There's been some discussion recently about provers and their requirements, hardware, electricity. I'm curious, what's the Drake take on how that will age like fine wine too?
Okay, so this is the Drake take. Let me kind of go through this in detail. So in 2022, Succinct, the company behind SP1, founded itself over the whole premise of snarkifying the beacon chain. And what they were doing, basically, they wanted to build bridges or whatever it is, Oracle and whatnot. And what they achieved was using a very, very powerful machine, like this beefy workstation with a terabyte of RAM or whatever. They achieved to only snarkify the sync committee. And they had this throughput of once per epoch as opposed to once per slot, and they had extremely high latency. Now in 2025, what's happening is that RISC-0, who built a ZKVM, is revisiting this problem that Succinct was trying to tackle. And this is one of the talks this morning, so I won't ruin it. But what I'm hoping will happen for the beam chain is that we're going to have, everything will be green here, meaning that the prover can be a single laptop CPU, so like a single MacBook CPU. We'll be able to snarkify the full chain at every single slot with only one slot of latency, meaning in real time. And so the honesty assumption is extremely low. We just need one guy in the world who has a laptop who's willing to help out. And surely we have enough. And we can do a similar trick to the attesters. We could say, if your computer is powerful enough to snarkify the chain, for example, produce proof of a state transition in less than 100 milliseconds, then you're automatically enrolled. And you won't even realize that you're generating these proofs. But most of the validators, 90%, are still assumed to be on extremely weak devices.
I think this is, I don't want to go into a topic that maybe has been a Pandora's box that's been talked about many times, but I am interested in, you still hear a lot of debate on post-quantum about how close quantum really is, and even I saw recently some people saying that actually there's a lot of ink spilled for no reason. We maybe don't even need these post-quantum cryptography. The quantum computers will have a very hard time breaking these things. So in light of this kind of cloud of this uncertainty, when will post-quantum really matter? Like, how do you think about navigating that that dynamic?
Right. So I have the luxury of so I live in Cambridge, and the father of my son's friend is the founder of one of the largest quantum companies in the world. I get to pick his brain, and yes, he does confirm with me that like a lot of the headlines are just fluff. But he also very much acknowledges that there is a lot of real stuff, and he's actually extremely bullish, maybe also because he's biased, on the future of quantum. Now, I guess my take, regardless of the technology, is that the narrative, the FUD, is going to play to our advantage, whatever happens. Another thought that I have is that it's going to take a very long time for the operators move to post-quantum, and so we need to plan for this for this transition period. The way that I envision doing it is basically we have a hard fork where we allow the validators to specify a post-quantum key, and then there's a period of time, for example, 1 year, where they specify their key, and then at the end of the year, or whenever the Beam fork activates, only the subset of validators that have migrated over would be enrolled as Beam validators. And we want to make sure that this number is high enough, at 80% or 90%. So we might have to wait even more than 1 year. The other thing that I'll say, going back to the narrative, is that we're starting to see it with Bitcoin. So for example, recently BlackRock had this addition to their ETF prospectus. And this is something that I can share. The cryptography team, for example, had a call recently with BlackRock, right? Just to explain to them what is the situation on Ethereum. And even if the fundamentals of quantum are still maybe a decade out, or maybe 15 years out, the narrative is just going to get louder and louder and louder. And I think we need to, because Ethereum sells security, I think the only reasonable approach here is to be maximally conservative. And
I just wonder, if everything evolves so fast, how do you see writing specs process? Is it like updated?
Yeah, great question. Yeah, so the way that I would tackle the spec writing is the divide and conquer, right? So I would start with subspecs for individual modules. We already have a subspec for 3SF written by Vitalik. We already have a subspec for one of the most complicated pieces, which is the aggregation of signatures by Emil. I want to see just all of the subspecs written out and full modules, like for example, the post-quantum module being the combination of multiple subspecs. And then from a timing perspective, what I would do is basically only put the pieces of the puzzles together once, once we're no longer at the do not disturb the devs thing. Because what will happen, I expect, is that once we make a big announcement saying, hey, we have a fully featured spec, there's going to be FOMO, and then all of the teams will want to be one of the first to implement. And we don't want that to be disruptive to the short-term objective of scaling DL1, scaling DL2, and improving UX. So yeah, it's a little bit of a political and tactical balancing act.
Why do you think you should not disturb the devs as opposed to having them engage on the new chain?
Yes. Okay. So.
In order to size to piece in the middle.
Yeah. So the mental model that I have is that it's 10 to 100 times less expensive to do research and to provide feedback than it is to write code. And we kind of saw this historically with the Beam spec, with the Beacon spec, where the researchers would whip out a new spec every month. And then the poor developers, they had spent 6 months implementing it, and now they have to restart from scratch. And so I think we should have the devs be engaged using this lightweight feedback mechanism, but we should not have them write a single line of code. Like all of the code that they write should be on the current Beacon chain.
In your slide about going to a laptop CPU, why is it a CPU? Why can't you just do a GPU on a laptop?
Because if a CPU is possible, why not do a CPU? And back of the envelope suggests that CPU is fine. So a single CPU today can do 2 million Poseidon 2 hashes per second. The Beam chain state transition function is essentially just signature verification, and it's way, way less than 2 million. So the ideal outcome is actually maybe 10% of a CPU should be enough to smartify the whole Beam chain. Okay, thank you so much for the questions. Next up, we have Dimitri from the Ethereum Foundation.